So in this lecture, we want to go from an unbalanced redox reaction. We're going to follow 7 steps that I've outlined in another lecture and want to get a final net balanced redox reaction. So let's follow these 7 steps. In the first step, we want to find or determine the oxidized atom and the reduced atom. So let's find the reduced atom first. So which atom gains electrons? So I've written out the oxidation states for each atom. So let's see which atom becomes more negative. So our Mn or permanganate atom goes from a +7 to a +2. That means it gains 5 electrons. So that means our Mn is reduced. Now likewise, let's find the atom that loses those electrons. Well, our carbon atom is +3 on this side and +4 on that side. And that means when it goes from here to here, it is oxidized. It loses those electrons gained by this Mn. So, our carbon is oxidized. We're done with step 1. Let's go to step 2. In step 2, we want to write out the 2 half reactions for our unbalanced equations. So we want to write out the oxidation reaction and the reduction reaction. So oxidation basically states that this guy goes from this guy to this guy in here, and in the reduction reaction, our ion goes to this ion. So this is our reduction reaction. Now I combine steps 3 and 4. In step 3, I basically want to balance out the atoms that are not oxygen atoms and not hydrogen atoms. So let's start with oxidation reaction. So in the oxidation half reaction, let's balance out the carbon atoms. So to balance this carbon atom out, there are 2 atoms on this side and only 1 atom on this side. That means I want to multiply this guy by 2. And that's exactly what I do here. Now I have 2 carbon atoms on this side and 2 carbon atoms on this side. Next, I want to balance out the the Mn atoms on this side, in this reduction reaction. So since I have 1 Mn here and 1 Mn here, it's already balanced. So in the 4th step, let's balance out the oxygen molecules by adding water molecules, and let's balance the H atoms by adding H+ ions. So let's see. Our oxidation reaction. So we have 4 O atoms on this side and only 2 atoms on this side. But I already multiplied this carbon dioxide by 2. That means our oxygens are already balanced out. So I have 4 here and 4 here, 2 times 2. So the oxygen is balanced out. Let's balance out the H atoms. I have 2 atoms on this side and no H atoms on that side, right? So in order to balance this, I have to add 2 H atoms on this side. That's exactly what I do. So I'm done with my oxidation half reaction. Let's look at the reduction half reaction. Remember, the Mn's are already balanced out. So let's balance out oxygen. I have 4 oxygen on this side, so that means I have to add 4 water molecules on this side. If I add 4 water molecules on this side, I balance out the O, but now I have to balance out the H, because now I have 4 times 2, 8 H ions on this side, or atoms on this side. That means I balance this guy out by adding 8 H+ ions to this side, and I get this following reaction. So I'm done with steps 3 and 4. Now let's go to step 5. In step 5, we basically want to balance out the entire charge found on this side and this side, and then the entire charge found on this side and this side. In other words, on this side of the oxidation half reaction, our charge is neutral. On this side, it's not neutral because we have 2 positive charges. So this side is neutral, this side is +2. So to make this side 0, I have to add 2 electrons. That's exactly what I do. And now my charge is neutral and neutral because these 2 pluses cancel with these 2 minuses. Now let's follow the same steps for this reduction reaction. So on this side, I have a -1 and 8 pluses. That means our charge on this side is +7. Now on this side, my charge is +2. So I want to neutralize my charges. That means if I have plus 7 here, I have to add 7 electrons, and that's exactly what I do. Now on this side, to neutralize this charge, I have to add 2 electrons. That's exactly what I do. I add 2 electrons. But now notice that I have 2 electrons here and 7 electrons here. That means I could subtract 2 electrons from both sides, and what happens is this guy cancels out, and this guy becomes a 5, because 7 minus 5 is 7 minus 2 is 5. So I'm done with step 5. In step 6, I want to consider the fact that energy or charge is conserved, like mass is conserved. And that means I have to, whatever amount of electrons lost by one atom or by one side has to be gained by another side. So, notice on this side I have 2 electrons. On this side I have 5 electrons. That means I want to find a factor or a common factor of 5 and 2. And this factor is 10 because 2 goes into 10 5 times and 5 goes into 10 2 times. So, I basically multiply this whole guy out by 5 and I multiply this whole guy out by 2. And I get the following. So 5 times this guy gives me this, 5 times this guy gives me this guy, 5 times 2h gives me 10h, and 5 times this guy gives me 10 electrons. I multiply this whole guy by 2, I get 2 of these guys, plus 16 of H pluses, plus 10 of E's, equals 2 of these guys and 8 of these guys. Now when I go from step 6 to 7, I basically want to add these equations up. Right, I want to add my 2 half reactions. So I add all the guys on the left side, and then I add all the guys on the right side. So I get this whole guy plus nothing more on this side, so I go down to my other reactions, plus 2 of these guys, plus 16 of these guys, plus 10 electrons. And now I'm done with everything on the left side. Now I move on to the right side. This guy equals 10 carbon dioxide molecules plus 2 Mn2 plus molecules, right? Plus 10 H plus molecules plus 8 water molecules plus 10 electrons. So this is my equation. Now my next goal, before I get to my finalized answer, I have to cross out some things. The first thing I cross out is the 10 electrons. So we have 10 electrons here and 10 electrons here. That cancels out. Next, notice that I have 16 H plus ions on this side and 10 plus H ions on this side. That means I could cancel out this guy by subtracting 10 H plus from this side and 10 H plus from this side. So that cancels out, and 16 minus 10 is 6. So my final equation, my final balanced redox equation, is 5H2C2O4 plus 2MnO minus 1 to the 4 plus 6 of these guys, because I subtracted 10, gives me, these guys cancel, 10 carbon dioxide plus 2 of these guys and 8 water molecules. And this is my final net redox reaction, and it's balanced.